to another session in Hort Americas TV. Today, I am super excited because I have worked really hard to bring complex information to an easy language in order to understand how can we estimate yield based on light in a short video. Let's start providing the great source of information that we have used. You can find all the information provided in this video in these two articles led by Dr. Bookby. Now, we're ready to start. I need all your attention here. Let's start with an easy question. Can we relate yield to light? This thing is pretty obvious, right? Of course, we can relate yield to light. Now, can we estimate yield based on light? Well, the answer is also yes. You have probably already listened that 1 gram is equal to 1 mole. If not, let's start from there. 1 mole of photosynthetic photons is required to produce 1 gram of dried biomass, which is yield. In order to understand where these numbers are coming from and how can we use them, we need to learn about photosynthesis, efficiency, respiration, and harvest index, at least, because there are a lot of things that we can learn about when trying to understand photons and yield. So let's start with photosynthesis. We all learned that plants need CO2 and water to produce energy. Plants use light in order to convert carbon dioxide and water to carbohydrates and release oxygen. So how much light is required? We know plants need about 12 photons of light to make carbohydrates, which are equal to 30 grams per mole. So how efficient is this process? Let's move now to efficiency. Efficiency is equal to output divided by input. In this case, when 30 grams is divided by 12 moles of photons, efficiency is equal to 2.5 grams per mole. Now, let's speak about something that is related to photosynthesis. Respiration. So, what is going on with respiration? When working with plants, we usually hear about net photosynthetic rate. This is the way we use to measure photosynthesis. Net photosynthetic rate refers to the total rate of fixation of carbon without considering the CO2 lost during respiration. Therefore, when trying to link light to yield, we need to consider that some percentage of carbohydrates will be used for the plant's respiration, impacting, of course, also the yield. So now we understand why we need to consider respiration when trying to link light to yield. So if we were considering respiration, we need also to know the efficiency of respiration. So in experiments, we have learned that efficiency of respiration is about 60%. We can calculate this by dividing net photosynthesis by gross photosynthesis. In order to consider the impact of respiration in photosynthesis efficiency, we need to multiply photosynthesis efficiency by respiration efficiency. The result will be what we call photon conversion efficiency. And in here we have 1.5. 2.5 multiplied by 0.6 is equal to 1.5. Here is the number we've been looking for. But it was not 1? Well, this calculation will make sense only if all the photons were absorbed by the plant. So this is why we don't use 1.5 and we assume just 1. Because it's really hard to get all those photons into our plants. And here is another topic that is really interesting. So we really need to optimize, mostly in indoor systems where artificial lighting is used. We really need to optimize the use of light in the systems. We need to light really good light incidence over our plant. Depending on our system, we can optimize light incidence, but it's really hard nor impossible to have all photons emitted absorbed by our plants. When we understand how plants use light, we are able to analyze our system better. For example, in an indoor operation, now we know the importance of the design and light incidence. Secondly, we can also estimate how much can cost to produce different crops on indoor facilities. This obviously is just related to light. So let's move to the last concept, harvest index. Harvest index is the ratio of usable or edible product to total plant biomass. For example, for many crops, we considered a harvest index around 50% because we grow a plant and we harvest fruit. Therefore, we're consuming about half of the total plant biomass. This can be a good number for tomatoes, cucumbers, but for example, for leafy greens, is a little bit different. In lettuce, we have a higher harvest index because we consume almost the whole plant. This information is important when trying to relate light, yield, and cost in an indoor system. We can use the cost of photons as percentage based on harvest index. For example, based on the amount of photons and harvestable material from lettuce, in ideal conditions, we could assume that the cost of photons as percentage of the market price will be about 5%. In comparison to other plants with higher harvest index, such as tomatoes, where the cost of photons can be around 18%. For plants where harvested material is low in comparison to the total plant biomass produced, cost of production based on the use and cost of light will be higher. This is why most indoor facilities are focused on leafy greens. Of course, we don't forget that LED lighting can also be used as supplemental light for many crops, where we are able to use free sunlight but also improve growth and quality by adding supplemental lighting. Well, that was a lot to take. If you like this content, I totally recommend to check the articles that I mentioned at the beginning. So, photosynthesis and the use of photons can be a complex topic. But if we really want to have control over our crops, we really need to pay attention and understand photosynthesis, which is one of the most important process in a plant production, or probably the most important. I hope you enjoyed this session. These kind of topics are really exciting to me, so I hope you also enjoy this video. Please let me know if you like this kind of content and we will be able to produce more. My name is Carla Garcia, Hort America's Technical Service. See you in the next video.